Morning, Assalamualaikum. I have uploaded the previous recorded lecture just this morning. Okay, so I want to recall a bit on the bisection method on our last class. Okay, since some of you still confused on how to replace the XL XU. Okay. Now last class, we based on this, right? When fxr is positive, so xr equals to xl. We base on the condition from the previous slide. This one, okay, I just recall a bit, okay? This one, positive, so xl equals to xr. Okay. Another method is to make it easier. You see the sign fxr here is positive. Okay, fxr positive. So you replace the next iteration, this positive, replace the positive value. Replace under the positive value. First iteration, fxl is the positive one, right? So the next iteration, you replace the positive value. fxu is negative. So don't disturb on this part. We just replace the new positive value, okay, for the second iteration. Then for the second iteration, you get fxr negative. Okay, so you replace the negative value of the fx. Okay, so that's why it comes to here. Negative, replace the negative value previously. The previous negative value. If positive, replace the previous positive value. That one we focus on the fx value. Okay, so it's up to you how you want to memorize it, how you want to understand it. According to the condition, if fxl multiply with fxr, okay, fxl multiply with fxr, if negative, xr will be the xu. Okay, or else you just replace this negative fxr value to the next, to the previous fxr fx value. We play around with this value only if to replace the value positive and negative. fxl, fxu. Yeah, did I make you confused or not? Can get it or not? Okay. Okay, I just want you to do another exercise on this bisection. We had done this. All of you tried until the 6th iteration, right? Last time. Now, try this question. This is also from the previous final exam question. Okay, here we have, you are given equation of concentration of the dye in wastewater plant. Okay, it changed according to this equation. You see, in final exam, usually the equation is much more, not to say complicated, but not common as y and x. Okay, here you see C. It changes based on the P. P here is the pH. Concentration changes according to the P, the pH. Okay, so for the dye concentration, it asks you to find the pH, which is the P. P in this case is your X. For the dye concentration C to reach 100 using bisection method with initial gas of pH 3 and 5. Stopping criterion 10%. Okay, so here it gives you C equals to 100. Initial gas here means XL and XU. So your XL is 3, XU is 5. Stopping criterion here means what? ES. ES equals to 10%. Okay, it asks you to find P. So substitute all the infos that you have. C equals to 100. So we need to generate the equation where the left-hand side is 0. Okay, substitute all the infos that you get. Okay, this one is the given. Now we want to generate left-hand side equals to 0. So what you do? 100 bring to the right side. Okay. So here, Y. Sorry, not Y. Okay, 0 equals to minus 100. Okay, so this is the equation that you will be using for the bisection method. Remember, bisection method, how to calculate your XR. Correct. XL plus XU over 2. Okay, then for the iteration, list out what are the infos that you need. XL, XU. What else? FXL, FXU, then XR, FXR, EA. Okay, so first iteration, XL is 3, XU is 5. Find out your FXL, FXU. Then you can find the XR. What you get for your FXL? Minus 6. 16. What you get, Sabah? Minus 4.3. 3125. FXU. Anis, what you get? Correct. 55.3377. Naresh, what you get for your XR? 4. Ariana. You are Ariana, right? FXR. Positive or negative? Positive, yes, correct. Positive 24.932. EA, what is the EA value? No, nothing yet, because we don't have the previous value yet. Okay, so for the second iteration, this 4 of the XR belongs to which? XL or XU? Huh? XU, because replace the positive value. Okay, FXR is positive, so replace the positive value. It replaced under FXU. So the 4, the XR, belongs to XU. XL remain, FXL remain. Then find out your new XR and FXR. Okay, try to do it. Let's see what you get for your week. get 3 iteration, right? Okay, until third iteration, you will get your XR is 3.25. The second iteration, what you get? XR? 3.5. Okay, so 3.25 with EA of 7.69. Okay, as long as the EA below 10%, you can stop already. The stopping criterion here is 10%. Okay, anyone having problem? Okay, let's give 5 minutes for the rest to settle. How do you set this equation? E power 0.2p. How do you set in your calculator? E bracket 0.2 multiplied by p close bracket. Okay, if you put E power 0.2 then multiply p, it will be different. Wrong answer. Okay, this part need to be careful. Okay, Rabia, can you get it? Okay, I proceed with the next subtopic, the next method. This one later I will conclude. Okay, the next method, which is the false position method. Okay, last time in bisection, to find the XR, we use the equation, this equation. Okay, sorry. This one is bisection method. Okay, where the XR is cut half between XL and XU. Okay, but in false position method, it have different assumption where it assume in between, I use this one. Okay, in between, this is XR, let's say this, XR is when Y equals to 0. Okay, so here XR, here is your XR. So it has its own gradient. XU and XR, and also between XR and XL. Okay, in false position method, the assumption is this gradient gradient 1 is equals to gradient 2 in false position method. Okay, so from here, how to find the gradient? Y2 minus Y1 over X2 minus X1, correct? Okay, so at XL, we have YXL. At XR, we have YXR, which is 0. XU, we have YXU. Y is equals to Fx. F, huh? Okay. Sometimes you see the term as F, sometimes you see the term as Y. Okay, so now to find the gradient, 1 equals to 2. I erase this side. So gradient 1, what is it? Fxu minus Fxr equal, over Xu minus Xr. Right. Gradient 2, Fxr minus Fxl over Xr minus Xl. Right. Okay. Now our aim is always to find the XR. Now you need to rearrange in order to get XR on the left hand side. Okay, so how we do it? Multiply both sides. But before that, we know that Fxr is equals to 0, right? This one cancel out already. Okay, so multiplying both sides. Fxu multiply with this part, then this part is negative Fxl multiply with Xu minus Xr. Okay, so do the maths, then you will get your XR on the left hand side. Okay, up to here. So bring both XR with the XR to this side. Sorry. Where is it? Okay, so now extract the XR. Over FXU minus FXL. Okay, so this is the false position method equation to find the XR. This equation will be given, no worries. Here, I want to show you how you can derive the equation. What is the assumption of the false position method? Okay, and how at the end it get to this equation. Okay, as engineer, you need to know how to derive the equation. Not only just use, okay? Okay, so this is the false position method equation. This one will be given, no worries. In your slide, you see a slightly different equation, but it originated from this one. They just rearrange the equation. Okay, in the slide, you will see this equation. Okay, so basically it's just the same. They rearrange it. Okay, you can try to rearrange so that you get the same equation as here. This is the one that we derived just now. So in midterm test or final exam, you can use either one of the equation. Sometimes either one of the equation only will be given. Okay, it's either this one or this one. So you need to know which belongs to which. False position and also bisection that use equation. Bisection, just the simple equation. So this one you need you know how to differentiate already. This one belongs to bisection. So the rest belongs to false position. Okay. Okay, up to there. Can Now the approach is similar. Do the iteration, but for false position, this is the equation that you need to use. Okay, we go back. This one as I explained earlier. We go back to the example last time. Using the same example where you are given this equation, but now using false position method to find the XR. Okay, so we start with the first iteration. First iteration, XL, we have 10. We are given as 10. XU, 20. Okay, FXL, last time we have calculated, which you get positive 0.0135. FXU is negative 0.585. Sorry, 585. Okay, now calculate XR using the false position method. Peto, what you get for your XR? For the first one, XR, using false position method. This equation. Now we are using false position method. So your XR must use this equation. Fifteen is you use bisection. 10.23. Okay, you should be getting 10.23 for your XR for the first iteration. Then find your FXR. You'll get somewhere this value. Okay, so for the second iteration, your FXR will be XL or XU. XL. XL. Okay, because positive, FXR is positive, so we replace the previous positive figure. Put it here. So this one falls under FXL. So your XR is your XL. XU remain. Then FXU remain. Find your new XR and FXR. stopping criterion is 2%. So once you get K less than 2. Okay, so your root when EA lesser than 2% will be 10.66. This one using false position method. XR, the one that you calculate, you are using this equation, isn't it? Right. So try to use the equation from the slide. Will you get the same answer or not? This one. Just to confirm that you will get the same answer. Get the same answer, Alif? Just any XR value to confirm this one is same value if you use from the derived equation just now. Same, right? Okay, so same. Okay, so either equation is correct. Now, from the false position and also the bisection, check back the same example on the bisection, what you get for your XR with ES lesser than 2%. What do you get? The one that we did last time. 15, right? This one, right? This one using bisection. Okay, but using false position, what you get? 10 something, right? By right, if to prove with the graphical method last time, what is the rule? The graphical method. Sorry, here. The first method is the graphical method, right? So from the graphical method, what you get your root? 17, 16, 16.5. Roughly there lah. Okay, 16 or 17, right? From the graphical method, it is proof your XR when Y equals to 0 is around this figure, 16 or 17, okay, from the graphical. But from the bisection, slightly different. It reduced to 15. Okay, bisection 15, 15.9. But then when we try with false position, you get 10 only. So what can you conclude? Okay, actually, false position, if you can see the gap, the difference between XR and the range, much more closer, smaller numbers compared to the bisection. Your bisection, the first XR is 15. You already cut into half. Whereby the false position, closer to the XL, the lower value. So it increased. As you can see over here, it increased by just a small numbers different. Okay, even though the EA is also lesser than 2%. But it is not approaching the actual XR yet when it passed through the axis, which we proved from the graphical method last time. Okay, so force position method, when it use equation, it is solely depending to the EA that you need to follow. Stopping criterion. Okay, but to prove whether your XR is really crossing the line, you need to prove using the graphical method. Okay, for the calculation, force position and bisection, it use equation. To prove your result, you can prove it using graphical method, where you can see it clearly. Okay. So for the force position, in order for you to reach 15 or 16 something, you need to do a lot of iteration over here. Okay, it doesn't mean force position is wrong over here. Certain case, force position is better to be used. Okay, it is based case on case basis. Certain case, bisection is better to be used because bisection, we can use shorter iteration to get closer to the root, to the actual root. Okay, you can see here, third iteration, we get only 10.66. In the bisection last time, how many iteration that you get until 15? 15.9. 6 iteration. Then it is already closer to the actual using from the graphical, right? Okay. So now here it shows you the difference from each method to each method. Okay, now let's try this this question last time. Now using force position. We had done with graphical bisection. Now try with force position. XL is 0, XU is 2. Okay, so the equation last time, the one you already obtained, you can copy back the equation. Let me copy the equation back. Where is it? Okay, this is the equation that we had generated last in the previous example. Final answer, you should be getting the XR here. Stopping criterion also 5%. So you can stop your iteration when you get EA lesser than 5%. Alif, what is your first XR just now? 1.34, is it? 1.33. XR2? 1.4. XR3? 1 point? XR4, then only you get this. Okay, this is the trend of the XR. Similar to Go Petong, is it? Similar to your numbers for the XR value. Okay, good. Until fourth iteration only. So if your XR trend is different, check back your calculation. Okay, sorry. What did I do? Okay, so we are done with the false position method. Chapter 2A, locating root with bracket method. We have graphical, we have bisection, we have false position. Okay, the rest, this one, it conclude the method. You can try this example. This one is not covered yet because this one is using secant method. Okay, we will cover later. This one we had done just now. Okay, this one you can try to do it. I will, I think this one is in the exercise already. Never mind. This one later I will upload this recorded session. So you will see the question over here. You can try to do it for false position method. This one also previous final exam question. Okay, then this is midterm question. Okay, then that's it for the chapter 2A. Okay, try to do it. We'll check the answers in the following class. Okay. Okay, that's all for today. Thank you. Attendance, all attend.